Hello and welcome into lesson 3, the sample problems video for Precalculus 1. In this video, I'm going to be showing you guys examples how to do distribution, foiling, bunch of factoring problems, applying the binomial theorem. So let's get into it. As soon as I share my document camera. All right, so let's say we wanted to add or subtract, and we have 5 times x minus 4 minus 8 times x plus 3. So this kind of goes back to our order of operations. Do what's inside the parentheses, multiply, and then add or subtract. So first, I need to distribute the 5 to both of these. So 5 times x is 5x. 5 times negative 4 is minus 20. And then for the second one, I have to be careful with this sign because it's negative 8 times x, negative 8 times positive 3. So that's minus 8x and minus 24. Now combine our like terms. So for our x variables, 5 minus 8 is negative 3, so minus 3x. And then negative 20 minus 24 is minus 44. So your answer for that one should be negative 3x minus 44. And again, with the previous videos, I would suggest once I put the problem up, see if you can do it. See if from the lessons you were able to grasp what you needed to. If not, watch the video. Hopefully then it explains what to do, and once you start doing the homework ones, you'll pick it up pretty quick. All right, let's say we want to multiply 6x minus 1 times 2x plus 7. So this is two binomials that we are multiplying together. So we're going to FOIL this. So first, 6x times 2x is 12x squared. And this goes back to our exponent rules when we have the same base, x and x, add the exponents, 1 plus 1 is 2. So we get 12x squared. Outside, so 6x times 7 is plus 42x. Inside, negative 1 times 2x is minus 2x. And then last, negative 1 times 7 is minus 7. We always want to simplify as far as we can, so combine like terms. So I get 12x squared, 42 minus 2 is 40, so plus 40x minus 7 should be your answer for that one. Next one, 5x plus 6 squared. So again, go ahead, hit pause, try it out, come on back, see if you get the answer. All right, welcome back. So thinking about the binomial theorem, how many terms do I have to have for this problem? Well, because my n is 2, I need what? 3 terms. So if you said the answer here is 25x squared plus 36, that's absolutely incorrect. Because this thing really means 5x plus 6 times 5x plus 6. So when we do it, we get 25x squared plus 30x plus 30x plus 36. So that becomes 25x squared plus 60x plus 36. That should be your answer. 3 terms. There's the 3 terms. I hope you did that correctly. You did not make that mistake of just bringing in the 2. And then let's do one more of our distribution here. So x plus 4 times x squared plus 6x plus 5. So again, maybe go ahead, hit pause, work it out, come back. You can even fast forward, see if you got the answer right. Hopefully you did. If not, you can rewind a little bit. All right, welcome back. Let's see what we got here. So this one, we're going to have to do x times all of these guys and 4 times all of these guys, and then combine our like terms. So first, x times x squared is x to the third. X times 6x is plus 6x squared. X times 5 is 5x. Let me do them in different color pen here so you can keep it straight. So that was multiplying x by all of these. Now let's do -4 in the red. 4 times x squared, 4x squared. 4 times 6x plus 24x. 4 times 5, 20. So that's the second set of 3 numbers that you should have got. And now start combining our like terms. So x to the third, I only have the 1 at the start. X squared, I have 6 and 4, so that's 10. So plus 10x squared. 5 and 24, that's 29x. And then all that's left is 20. So you should have x to the third plus 10x squared plus 29x plus 20. So hopefully you guys did okay on those distribution problems. Those are the different types you'll see. Just some straight distribution, combine your like terms, some foiling, some binomial squared, some polynomials that you're multiplying together. Now let's get into our factoring problems. Let's go factor completely. So the first one we have is 2x to the fourth minus 8x to the third minus x squared. Okay, so what can I factor out of here? Well, the only thing I can do is factor out a common term, which is what? My x squared. So I'm going to take out x squared, and what does that leave me? Well, how many terms did I start with? 3. How many terms do I need to end up with? Also 3. Because remember, if I distribute this x squared back, I should get the original. So when I factored out the x squared, essentially what I would be doing is dividing all of this by x squared. If we think back to our exponent rules, when I'm dividing variables or dividing terms that have the same base, we do what? We subtract the exponent, subtract the exponent, subtract the exponent. So I'm left with this 2. 4 minus 2 is 2. So 2x squared when I take out an x squared. Minus 8. 3 minus 2 is 1. So I'm left with 8x. And now be careful here. 2 minus 2 is 0. Anything to the 0 is 1. So I have minus 1. Do not forget that placeholder, because again, if I left that off and then tried to distribute this back, I'm not going to get the same as I started with. So I need that minus 1 for a placeholder. So that's it. That's as much as you can factor that one. The second one, let's factor 5x squared minus 11x minus 12. So you could do guess and check. Okay, 5 and 1, 1 and 12, 2 and 6, 3 and 4. How do I get 11? This is kind of messy. So let's try our bottoms up method. So 5 times negative 12 is minus 60. So rewrite it without the 5 in the front. So x squared minus 11x minus 60. So now I need to come up with values that multiply together to get 60, but if I add or subtract them, I get 11. So obviously it's not 1 and 60, not 2 and 30, not 3 and 20. Wait a minute. 4 and 15. So I want a minus 11. So if I have 4 minus 15 is negative 11. And 4 times negative 15 is negative 60. So that means I can factor this guy into x plus 4, x minus 15. And again, if you remember on the lesson video, I goofed that up. So let's double check. X squared plus 4 minus 15, negative 11. 4 times 15, negative 60. Okay, but we're not done. This is the factoring for this guy, not for that one. So I do what? I divide everything by the original a. So I get x plus 4 over 5 times x minus 15 over 5. Simplify if I can. Well, I can't simplify 4/5, but I can simplify 15 over 5. That's 3. And now if I have any denominators, move them in front of the x. So I get what? 5x plus 4, x minus 3. But this is on a test. And I had to factor this. And I want to know, do I have this right? Before I get up and go hand my test to George, is this one going to be right or is he going to mark me wrong? Well, let me check. 5x times x is 5x squared. Minus 15 plus 4 is minus 11x. 4 times negative 3 is minus 12. You know what, George? Just give me 100 because I know I have it right. I checked my work. It works out correctly. I know that's right. So that would be your answer for number 2. Number 3. So factor 9x squared minus 4. Wait a minute. I remember George telling us if I see two terms and a minus sign, ask myself, is this a difference of squares? Well, 9x squared could be written as 3x squared, and 4 can be written as 2 squared. So, he's trying to be tricky. This is a difference of squares. So if this is my A and this is my B, this becomes what? A plus B and A minus B, or 3x plus 2, 3x minus 2. That's it. You're done. Number 4, x to the third plus 2x squared plus 8x plus 16. Wait a minute. 4 terms. I know he told us something about 4 terms. Factor by grouping. So what do? I group the first 2 together. I group the second 2 together. And now I look for common factors. What can I take out of these first 2 terms? Well, I can take out an x squared. So when I do that, what am I left with? X plus 2. Now, here's the nice thing about factor by grouping. If factor by grouping is going to work, the only way that it's going to work is if this guy also ends up with an x plus 2. So what can I take out of here to end up with an x plus 2? Well, it's a what? It's a 2. No, it's not. It's an 8. Sorry. Getting ahead of myself. 8. Take out an 8, I get x. Take out 8, I get 2. So now I have an x plus 2 here, and I have an x plus 2 in this term. So since I have a common factor, I can take it out of both, x plus 2. And what am I left with? Well, in this first one, when I take out x plus 2, I have just x squared. And in the second one, when I take out x plus 2, I have a plus 8. So I end up with x squared plus 8. So that is how we factor that one. All right, number 5. So many different types of examples, but that's good. So I want to factor 5x plus 1 squared plus 11 times 5x plus 1 plus 24. I got to factor this? Well, I guess I could square this and then distribute the 11, then combine all my like terms. then try to use bottoms up method to see if I can factor this. That's a lot of work. There's an easier way to do this. So in math, and we're going to be using this a couple more times this semester, we have something called U substitution. And we use U substitution. And if you guys are going on to Math 181 calculus, you're going to use it a lot. So get real familiar with U substitution. What we do is we take the messy part of the problem and I substitute it for U. So what I'm going to say here is that U is equal to 5x plus 1. So anywhere in the problem I have 5x plus 1, I'm going to change it to U. So I get what? I get U squared plus 11 times U plus 24. This is a lot nicer to factor, a lot easier to factor. Because I get what? U plus 8, U plus 3. So FOIL it back, U squared, 8U plus 3 is 11U, 3 times 8 is 24. But hold on, because we did not start with U in the problem. We started with X's. So before I'm done, I now have to plug this back in for the U. So instead of U plus 8, I have 5x plus 1 plus 8. Instead of U plus 3, I have 5x plus 1 plus 3. Now go ahead and simplify. 5x plus 1 plus 8 is like 5x plus 9. And 1 plus 3 is 4, so 5x plus 4. So this would be the factoring of that guy there. Using U substitution takes something that looks pretty messy and makes it a whole lot more feasible for us. Okay, that's our factoring, all the different types of factoring problems you guys should know how to do and you'll encounter on your homework, on your in-class assignments. Let's get to binomial theorem. Let's say we want to expand 2x plus 1 to the 4th power. So we could do this with binomial theorem. We could do this with Pascal's triangle. Again, it doesn't really say what method we have to use, and it won't say on the test. It's just going to say expand. You could also, if you're really in a pinch on an exam and you don't know what to do, you could FOIL 2x plus 1 times 2x plus 1 times 2x plus 1 times 2x plus 1. And pray to God you don't make any mistakes, because otherwise the whole thing will be a disaster. But if I use Pascal's triangle, and I'll show you how to do that here. When it's to the 4th power, that means we have what? We have 5 terms. So if I look at my Pascal's triangle, the row that has 5 terms is what? 1, 4, 6, 4, and 1. So these are all the binomial coefficients. N choose 0. Well, in this case, 4. So 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. I'm just not calculating those because I can get them from Pascal's triangle. Then it's going to be what? It's all my A terms, which is 2x, starting at n. You remember those general rules that always apply? So it's 2x to the 4th, 2x to the 3rd, 2x squared, 2x to the 1st, and 2x to the 0. Anything to the 0 is 1, so I'm not going to write that. And then my b, which is 1, starts at 0 and goes up by 1. So 1 to the 0, 1 to the 1st, 1 squared, 1 to the 3rd, 1 to the 4th. I started with 5 terms, 5 coefficients. I need to end up with that much. So my recommendation to you is that even if you're not a big fan of using parentheses, put them in when you're doing binomial expansions. Because if you don't, you're going to lose track. Well, what's to the 3rd power? What's to the 2nd power? What am I multiplying? What's just addition? What's What's subtraction if I had minus signs in there? So put your parentheses in and then simplify it. So this one, this 4 applies to both of these. So I have 2 to the 4th power, which is 16, x to the 4th and times 1. So just 16x to the 4th. This one, 2x to the 3rd. So 2 to the 3rd is 8. X to the 3rd is x to the 3rd. And then times 4, so 32. So plus 32, x to the 3rd. Here, 2 squared is 4. So this is 4x squared. 1 squared is 1. 6 times 4 is 24. So 24x squared. Nothing on the 2x in this time. 1 to the 3rd is 1. So it's just 4 times 2 is 8. So plus 8x. And then 1 to the 4th power is 1. So that should be your answer for the expansion of 2x plus 1 to the 4th is this guy here. So that's how you would do it. Let's do one more so you can kind of hit pause, try it yourself. Let's do x minus 2y to the 3rd power. We'll keep it so it doesn't get quite so big on us here. So hit pause, try to do this one exactly like we just did, then come back, see if your answer is right. Welcome back. So we do what? First, look at our exponent, 3. That means what? I need 4 terms. So if I look at Pascal's triangle, it's got 1, 3, 3, and 1. My A term here is x. So I start at x to the 3rd, then x squared, then x to the 1st, x to the 0. And then my B term is minus 2y. So minus 2y to the 0, minus 2y to the 1st, minus 2y squared, minus 2y to the 3rd. And now you can see why parentheses are so important here. So from this first term, I just get x to the 3rd. On this one, it's minus 2y to the 1st power, so this negative stays. So 3 times negative 2 is minus 6. And then x squared and y. And then this one, negative 2 squared is positive 4. So this term here is really 4y squared times our positive 3, so that's 12. So 12xy squared. And this one, negative 2 to the 3rd power, so negative 2 times negative 2 times negative 2 is minus 8, y to the 3rd power. So that should be your answer for this one. Let me point out one more thing before we get into the general term. If you notice, when we have a minus sign in our binomial, what happens to our sign? We went from plus to minus, back to plus, back to minus, and this would keep going on forever. So when I have a minus sign in here, I'm going to start with a plus, and then every term for the remainder of my answer should alternate from positive to negative, etc. Okay, something I wanted to point out there. And then lastly, so find the term containing x squared in the expansion of 2x minus 3 to the 10th power. All right, well, I know my n is 10. X is the a value here. So I want x squared, meaning my r is going to be 2. My a is 2x, and my b is negative 3. So now that I have all this, I just put it into the formula. So n minus r, so 10 choose 8. And then a, 2x to the r power squared. And then B, -3 to the n minus r, 10 minus 2 is 8 power. You will absolutely have to use your calculator on this. And so when you calculate all this out, you should get 1,180,980 x squared. So that is the term that contains your x squared term. Let me just double check my calculations before you're like, wait, I can't get that. 3/8, okay. Yeah, yep, that's what I got. Okay. So that'll do it. That wraps up lesson 3, the video with our sample problems for Precalculus 1. Should be a good start for you guys for the web assigned problems now. And good luck. We'll see you in class and then on to lesson number 4.